Hello there and welcome to a brand new lesson. This is How Beyond Numbers, where we learn maths the easy way. In this lesson, we are looking at relations versus functions. And by the end of this lesson, you should be able to define a relation and represent it using ordered pairs, tables, and mapping diagrams. You should be able to state the domain and range of a relation from any representation. You should be able to define a function and explain what distinguishes it from a general relation. You should be able to classify a relation as a function or not using mapping diagrams and the vertical line test. And finally, you should be able to identify and describe the 4 types of mapping. That is a one-to-one, many-to-one, one-to-many, and then many-to-many. So without much ado, pick your notebooks, let's learn together. So let's start by looking at what a relation is. A relation is simply any connection between 2 sets of values. Any connection at all is a relation. That is from the English word. So mathematically, a relation is simply any connection between 2 sets of values. Now it can be shown as a set of ordered pairs. That is one way of showing a relation. You can also use a table to show a relation. You can also use a graph to show a relation. And finally, you can use mapping diagram to show a relation. We will be focusing on function. Now, you should know that every function is a relation, but not every relation is a function. So then what is a function? So we say a function, on the other hand, is a special relation. You see, so a function is a relation where every input, that is the x value, maps exactly to one output, that is the y value. No x repeats with different y. What does this mean? To distinguish between what is and what is not a function, let's consider this over here. So we are going to call this the domain of what? Our relation. And to define domain, the domain is simply the set of all permitted input values. You see, that is the x values where we start our relations. So A is a domain, B is a domain, C is a domain. They are all the input values. Then we are going to call what we have here the range. The range, on the other hand, is the set of all the actual output values that are mapped by what? The input values. So if I'm to have another letter here, that is I, realize that I is not being mapped by any of what we have here in the domain. So I doesn't become part of the range. Even though we can say it is in this set, which we generally call the codomain, but it is not in the range. You see, so if you have to compare these two mapping diagrams, realize that for this particular one, each and every term is mapped to one and only one element in the range. On the other hand, what we have here doesn't do that. We have A mapping to 2 elements in the range. We have B mapping to 1, C mapping to what? 1. If you have something of this nature, we say it is not a function, right? For functions, they are only 1 to 1 or many to 1, such that each element in the domain is mapping only toward one element in the codomain. So we would consider the 4 types of mapping, and out of those, we would see those that are really what? Functions. So the first type of mapping we'll be looking at is what we call the one-to-one mapping. One-to-one mapping is such that each input, so all these elements here, that is A, B, C, and then D, they are all mapping to unique output. That is exactly one element in the what? Your range. This type of mapping is a function, and it is the best kind of function you would ever get. One-to-one mapping is a function. Why? Because each input maps uniquely toward an output. The second type of mapping we'll be looking at is the many-to-one mapping. The many-to-one mapping simply says you have multiple inputs, that is from your domain, that can share the same output. You see, now if you look at a function such as f of x equals x squared, that is to say f of x equals an x squared, then if our x is -2, we are going to get a -2 all squared. A -2 all squared gives us what? 4. If our x is a -1, it's going to be a -1 squared. -1 squared also gives us what? 1. If our x is a 0, we have 0 squared, which is what? 0. If x is a 1, we have 1 squared, which is also a 1. For 2, we have 2 squared, which is also a 4. The question is, there are multiple inputs here that map to an output. Is it a function? What did we say a function is supposed to be? A function is such that each element in the domain maps to only one in the range. So -2 has mapped to only one. -1 has also mapped to only one. 0 has mapped to only one element. 1 has also done same, and 2 has also done same. The main emphasis here is on the fact that the element here should have just one line moving away from them, and that is all. So we can also say that a many-to-one mapping is also a function, because as you can see, we have just one line moving from the input. If you are to read from the output, you can say, okay, there are 2 lines that are moving to 4, but that is not the issue at hand here. Most important thing is just one line should move from the input and then get a unique output. Then let's look at the 2 other examples of mapping that are obviously not functions. So when it comes to one-to-many mapping, as you can see, we say that what? One input produces multiple outputs. So an example is an x mapping to y squared. If we take 1 as an x, you see, and then we want its square, or let me rather say we want a number whose square is the value of x we have over here, then for 1 we can get what? -1 squared giving us 1, and then a 1 squared as well giving us 1. So it means that 1, which is in our domain here, maps to 2 elements in the range. For 0, it maps to only 0, because only 0 squared, that gives us a 0. But 4, on the other hand, you have -2 squared giving you what? 4, and 2 itself giving you 4. Looking at this, there are actually 2 lines from each element in the x or in our domain, and hence we would say it is not a function. The reason being that what? You can see there are 2 lines. So this one, and then what? This 2 lines. But for functions, we are restricted to just one line and only one line for all the elements in our x. But that is not the case over here. The last one, after which we solve some examples. For our last one, which is the many-to-many mapping, we say that we have multiple inputs connected to multiple outputs with no unique mapping. So if you look at what we have here, many of these elements are mapped to many of the element here, and many of these elements are being mapped by what many of the elements here. You can see two lines being produced from what A, that is with the golden color or orange color. And for D itself, there are two lines. So we have the yellow and then the orange as well. All of these have multiple lines connected to them or connected away from them. And that is what we call the many to many mapping. This type of mapping is also not a function. With all these, let's now solve some questions. So we are solving 5 questions in increasing difficulty. This is the first one and it is very, very simple. It says, state the domain and range of the relation. Now, this is our relation here, and then it has been given us in what? The ordered pair format. And we said the domain is the set of all the x values, that is the input. And the range, on the other hand, is the set of all y values, that is the what? Outputs. So, listing out what we have for the domain, we have what? The 2. So 2 from here, that is all the x values. You see? So 2, then a 4, 6, and then 8. These are our domains. Then for the range are the set of y values. So we have the 5, the 9, 13, and then 17. These are also our range, and that is just it for this question. Very simple, right? Okay, so let's build on this idea. Our second question here says, is the following a function? Is the following a function? We said a function is that which has what? A 1-to-1 or a 1 to what? 1 or a many to 1. So we want to check if any of the x values appear more than once with different y values. So for our x values, we have what? 1, 2, 3, and then 4. And for our y values, we have what? 3. We have 7. We have 3. And then we also have 4. And they are being mapped just one to each other. So 1 uniquely maps to 3. 2 uniquely maps to 7. 3 uniquely maps to what? 3. And we have our 4 uniquely mapping to what? What we have over there. So with this, it is clear that our mapping, each and every element in the mapping is being mapped to just one element in the range. Hence, it is a function. So yes, it is a function. Now, looking at how we have 3 and 3 here, we could have as well decided to remove this and take out this 3 and map the 1 all the way to the 3. That is this over here. You see? So, first of all, what type of mapping is this? This is a many to 1. And under functions, it's either a 1-to-1 or a many to 1, as I said earlier on. So yes, this is a function. It is a many to 1 function, which is allowed. So there's a third question which says, is this a function? So it's just like the previous one. Now we want to check if it is a 1-to-1 or a many to 1. If it is any of these, then it's a function. But if it is if it is a many to many or a 1 to many, then it is not a function. So we have 2, that is writing out what we have in our domain. There is a 2, there is a 5, there is a 2, and then there is a 7. That is 2, 5, 2, and 7. Okay. So since the 2's are 2, we should just remove this one. Then with that, we can see in our range, we have the numbers 4, a 10, an 8, and we also have a 14. You see? So with that, let's look at how they are paired against each other. So with this, you realize that from our domain, we have 2 being mapped to what? 4. So 2 is mapped to 4. Then we have 5 being mapped to 10. We have 2 again being mapped to 8. This alone is to tell us that there is something wrong. You see, so 2 is mapped to 8. And then we have 7 being mapped to 14. So 7 being mapped to 14. So with this, what type of mapping is this? At least there is an element here which is mapped to more elements, that is more than one. So it is a one to many. And under functions, we don't consider one to many as functions. Mappings are only one to one or many to one. So no, you can say therefore this is not a function. Why? Because our input 2, this one, this 2 over here, it gives 2 different outputs. So it is not a function. We have 2 more questions to go. Now, question number 4 says, classify each mapping type and state whether it is a function or not. Okay, so the first one says, every student in a class has one unique student ID. Every student, each student have 1 is to 1. Do you see that? So for the very first one, it is a 1-to-1 what? Mapping. Now if it is a 1-to-1 mapping, then we know what 1-to-1 mappings are. They are what? Functions. So for the first one, I'm going to write what? 1 is to 1. Then as to whether it's a function, yes, it is a function. Then we come to a number x maps to both root of x and then the negative square root of x. They are saying just one number mapping to 2. Just one number mapping to 2. What type of mapping would that be? So we have just one. That is one element mapping to how many? 2 elements. That is many. So 1 to many mapping. And that is not a function. A 1 to many mapping is not a function. Then our last one we have is a what? All students in a year group share the same teacher. They share the same teacher. Many students. All students. So we can say it's a many, and then they share the same teacher. So 2, 1. And many to 1 is also a function. You see? So this would be the classification of these we have over here. So for our last question we have here, it says the relation R is defined on the set A equals 1, 2, 3, 4. That is the set of A. By the rule x maps to x squared minus x. So the rule is simply what? We can rewrite it as f of x maps to what? X squared minus x. This is the rule. Okay. So with that, we have to state or list all the ordered pairs. So let's start with that. For the ordered pairs, we start by saying if our function f of x is given as what? X squared minus x. So evaluating what we have, for x being 1, we have f of 1 given as what? A 1 squared minus 1. 1 squared is simply 1, so 1 minus 1 we have a 0. Then for f being 2, we are going to get a 2 squared minus 2. And 2 squared gives us a 4. So 4 minus 2, we have what? A 2. Then for f of 3, we have a 3 squared minus a 3. 3 squared gives us a 9. 9 minus 3, we have a 6. Then for f of 4, we have a 4 squared minus 4. 4 squared gives us a 16. 16 minus 4, we have a 12. So writing these as ordered pairs, then we have 1 with what? 0. So 1 gave us a 0, followed by 2 pairs up with 2. So 2, 2, followed by what? 3 with 6. So 3 comma 6. Then the last one 4 and then 12. So we have 4, 12. Then we close our curly bracket. So this is our ordered pair. Now the next one says you should state the domain and the range. The domain and the range. So the domain is simply the set of x values. That is what we have here. Or 1, 2, 3, and then 4. So our domain is going to be 1, 2, 3, and 4. And on the other hand, our range is also going to be the set of y values. These we solved over here. So we have a 0, a 2, a 6, and then a 12. Now the last part of the question is asking whether or not this is a function. It is a function if it is either 1 to 1 or a what? Many to 1. And looking at what we have here, each element is mapped to 1. There is none that is being mapped to a double. You see? So we can say yes, R is a function. And what type of mapping is it? It is a 1 to 1 mapping. So that will be all for this lesson. I do hope it was helpful. As usual, I'll leave with some exercises so you try on your own just to test your understanding. So here are just 5 questions you can try on your own. Pause the video, attempt this before you move on so that you try as much as possible to enhance your understanding. This is How Beyond Numbers, where we learn maths the easy way. If this is your first time on this channel and you so do wish, you can choose to subscribe so that anytime I release a video, you'll be notified as well so that you come so we learn together. See you in our next lesson. Bye for now. Do stay safe.